Okay, so this video we'll talk about identifying special quadrilaterals. So first, let's look at the relationship amongst our quadrilaterals. The box as a whole represents all quadrilaterals. And then within that, we have some special quadrilaterals. We have trapezoids. We have kites. And we have parallelograms. And then if it's not any of those, if it's just a random quadrilateral, it would be outside of those figures. So within trapezoids, we have some special ones. Those are the isosceles trapezoids. Kites, there aren't any special kinds of kites. But within parallelograms, we could have rectangles. We could have rhombi. And where our rectangles and rhombi overlap, we have squares. So those are the relationships among quadrilaterals. Trapezoids, special trapezoids or isosceles trapezoids, kites, parallelograms, and the special parallelograms. So let's look at some examples. For example 1, quadrilateral ABCD has both pairs of opposite sides that are congruent. So what kind of quadrilateral could it be? Well, it's not going to be a trapezoid because my bases aren't congruent on a trapezoid. It's not going to be kite because the opposite sides aren't congruent on a kite. But it could be a parallelogram. It could also be a rectangle. Or a square. Or a rhombus. All 4 of those have both pairs of opposite sides that are congruent. Looking at the next example, quadrilateral JKLM has congruent diagonals. Well, again, if I go through my list of special quadrilaterals, trapezoids don't necessarily have congruent diagonals, but isosceles trapezoids do. So it could be an isosceles trapezoid. Kites do not have congruent diagonals, but it could be a parallelogram. Okay, so it could also be, it wouldn't be a parallelogram necessarily, but rectangles, a special parallelogram, have congruent diagonals. So it could be a rectangle, and it could be a square. All right, looking at the next example. Now I want to know what is the most specific name for quadrilateral PQRS. So for PQRS, it looks like a square, but the right angles are not marked. Therefore, I can't assume that it is a square, but I do see that all 4 sides are marked as congruent. So that means it's a rhombus. All right, looking at the next example. Now I've got QRST. I noticed that I've got 2 sets of congruent sides. QT is congruent to ST, and QR is congruent to SR. And the sides are not opposite each other. They're adjacent, so that means it has to be a kite. For example 5, is there enough information to show that FGHJ is an isosceles trapezoid? Well, I know that my missing angle, I can just call it X, and I know that all the angles have to add up to 100 or 360 degrees. So if I solve for X, I set that equal to 360. Combine my like terms, I get X plus 282 is equal to 360. And so X equals 78. And since X equals 78, that means that both pairs of base angles are congruent. So yes, there's enough information because both pairs of base angles are congruent. All right, then finally on example 6, is there enough information to show that BCDE is a rectangle? So again, I'm missing an angle here. I'll call it Y. If I add my angles up, they have to add up to 360 because it's a quadrilateral. Combining my numbers, I get Y plus 270 is equal to 360. Subtract 270 both sides, I get the Y is equal to 90, which means it is also a right angle. Therefore, yes, there is enough information because all 4 angles are right angles. And that concludes this video. Thank you.